Okay, so continuing on, the next problem that I want to work is number 9, since this is a SOHCAHTOA problem. Okay, so what I recommend doing to start off a SOHCAHTOA kind of problem is that you label your sides. So the hypotenuse is always going to be the hypotenuse no matter where your angle is, because the hypotenuse is always across from 90. So our hypotenuse would be the side that contains x. Now your opposite and adjacent depends on where your angle is. So this time our angle is here, meaning that across from that angle, that's going to be our opposite side. And next to the angle, that's going to be our adjacent side. Okay. Now I just want to show you that, for example, in the problem right before this, it's using a different angle. So in this case, this would be our opposite side, and this would be our adjacent side. So opposite and adjacent depend on which angle you're using. And opposite refers to across from, adjacent refers to next to. Okay, so then once we have this set up, sometimes my students get confused about which sine, cos, or tan to use. So what I'm going to suggest is that you just fill in each of these with your information. Okay, it tells you exactly what to use, just fill it in, and then it becomes more obvious which one will be helpful to you. So for example, it says sine of A is equal to your opposite leg over your hypotenuse, and A stands for the angle that you're using. Okay, so if I'm going to use sine, then I would write that sine of 60 is equal to my opposite leg, which is y, over my hypotenuse, which is x. Okay. Now I'm going to go ahead and write out the other two. So cosine of your angle is equal to the adjacent leg over the hypotenuse. Okay, so cosine of 60 is equal to the adjacent side, which is 8, over the hypotenuse, which is x. Okay. And then if I were to use tangent, tangent of A is equal to the opposite leg over the adjacent leg. So tangent of 60 is equal to the opposite side, which is y, over the adjacent side, which is 8. Okay. Now, when you look at these three proportions, okay, in two of them, there's only one variable that you're solving for. So with cosine, I'm only solving for x, which is doable. And with tangent, I'm only solving for y. There's only one variable for each of these. However, with sine, it's equal to y over x. This means that if you were to try and use this one, you're going to have to try and solve for both y and x at the same time. And we don't do that. Okay? So that's not going to help us. So in this case, I'm going to use cosine to get my x, and I'm going to use tangent to get my y. Okay. All right, so for the x, clear space a little bit. So we've got cosine of 60 is equal to 8 over x. Okay. You cannot type this into the calculator. I've had students try to do that before too. Your calculator is not going to solve an equation for you. You have to isolate x and get everything else to the other side of the equation, and then you can put it into the calculator. So if I'm trying to get x by itself, the first thing that I need to do is get it out of the denominator. Okay, so I would multiply by x to get it out of the denominator. These x's will cancel out. And on this side, now I have x times the cosine of 60 is equal to 8. Okay. All right. So it says x times cosine of 60 equals 8. If I want to separate these, then I need to divide by the cosine of 60. Okay. The cosines will cancel out, and now I have x is equal to 8 divided by the cosine of 60. And this you can type into your calculator, and it'll give you a numerical result. Make sure that your calculator is in degree mode. Okay, so you press mode, and degree should be highlighted in black. If it's not, like for example, if I reset this calculator, okay, then I need to go over, hit enter, and then it'll highlight degree. And you can press second mode to quit. Okay. And now you'll type in 8 divided by cosine of 60. And that gives us that our x is equal to 16. Okay? All right. Now, once you've solved for one of your sides, if you don't feel like using SOHCAHTOA for the other one, you can use Pythagorean theorem to get this, because now you have two sides. You're perfectly capable of using Pythagorean theorem. If you were to do that, in this case, y would be equal to the square root of 16 squared minus 8 squared. Okay. Now, because I want you to have some more experience with SOHCAHTOA, I'm going to show you the SOHCAHTOA method of getting y, okay, but just know that's another option. All right, so we said before, we already set it up, tangent of 60 is equal to y over 8. Okay? Before I put this in the calculator, you have to get y by itself. So right now, we're saying y divided by 8. I can get rid of that 8 by multiplying. Okay? Those will cancel. And I have y is equal to 8 times the tangent of 60. This you can put into your calculator. 8 times the tangent of 60 is equal to about 13.86. Okay. So that's our y. I want to point out that if you are aware of your special right triangle rules, so like my 30, 60, 90 rules, then this is representing our x, this is representing our 2x, and this is representing our x square root 3. So if I wanted to be precise, the real value here is 8 square root 3. Now, if you are more comfortable with SOHCAHTOA and you don't like special right triangles, that's fine. Your answer choices might be in square root form. That's also fine. You can convert them to a decimal by just typing it into your calculator, and it'll give you your decimal result. So if your answer choices are not in the format that you want, convert them to decimals and find which one matches yours. Okay, let's take a look at number 12. Okay. This is another SOHCAHTOA problem. Just wanted to show you this one as well. Okay, so this time around we have an isosceles triangle. We're given this angle of 70. We're trying to solve for x. Okay, so I'm going to start by labeling my sides. Across from my 90, that's the hypotenuse. Across from my angle, that's opposite. Next to my angle is adjacent. Okay. All right. So I'm trying to solve for x. I'm given my hypotenuse. Okay. So based off of what's going to be helpful to me, if I'm using opposite and hypotenuse, that goes with sine. Sine uses my opposite and hypotenuse. So if these are the numbers I want to plug in, then I need to use sine. Okay? So we would say sine of 70 is equal to x over 20. in order to get x by itself, I'd have to multiply by 20. Okay, those cancel. X is equal to 20 times the sine of 70. So that's equal to about 18.79. Okay. All right, the next one I want to look at is number 13. Okay. So it says below is a right isosceles triangle. So what's a little bit different about this one is that it's, at first, it looks like we're not given any angles, so we can't use SOHCAHTOA. But the key is in the wording. Since this is a right isosceles triangle, that means that these two sides are congruent, okay? And it also means that these two angles are congruent. So we could do 180 minus 90, the angle that you're given, divide that by 2, and that gives us that each of these angles is 45. Okay? All right, so if that's the case, we could use SOHCAHTOA at this point to solve for our A and for our B. Now, because this is isosceles, another method that you could use, since we know that this is 6, we also know that this is 6. So if I wanted, I could use Pythagorean theorem. Okay. The square root of 6 squared plus 6 squared is equal to about 8.49. Sorry. Okay, so that's my hypotenuse. Just want to point out, this is also following your 45, 45, 90 special triangle rules. So we've got 6, 6, and then this represents 6 square root 2. And if you don't believe me, just type it into your calculator. Okay, 8.49. Okay. Let's see. So flipping to the next page, I want to take a look at number 15. All right. So it says for quadrilateral ABCD, angle A is congruent to angle C, and BD is a perpendicular bisector of AC. It also tells us that angle B and angle D are not congruent. All right. So if you're going to solve a problem like this, you're going to need to refresh your brain on the properties of quadrilaterals. So there's 3 main groups. Okay. What marker should I use? Okay, so we've got kites, parallelograms, or trapezoids. Okay. All right. Kites have a certain set of properties. So kites, they look like this. Okay. They have one diagonal that bisects the other. They have no parallel sides. Okay. They have one pair of opposite angles that are congruent, one line of symmetry, and adjacent sides congruent. Okay. All right. Parallelograms. Okay. They have opposite sides that are parallel, and that means that they also have opposite angles that are parallel, and both sets of opposite angles are parallel. Parallelograms also contain rectangles, rhombi, and squares. Okay. Now, of course, rectangles, we can recognize those 4 right angles, opposite sides congruent. Rhombus, all 4 sides congruent, slanted, not necessarily right angles. Squares, all right angles, all congruent sides. Okay. On the other hand, trapezoids, they have one set of parallel sides and only one set of parallel sides. In general, that's mainly the only property that trapezoids have, is one set of parallel sides. However, okay, if you have an isosceles trapezoid, which means that it has a line of symmetry down the middle, okay, that means that these two legs are congruent. It means that these two angles are congruent, and these two angles are congruent because everything on this side matches this side. Okay. So these are just the basic properties that you want to be on the lookout for when working these kinds of problems. Now, what I suggest, okay, when working a problem, I suggest just drawing like any old four-sided shape. Okay. Now keep in mind that this is not what this shape looks like. I don't know what this shape actually looks like, but this is just for the sake of being able to label my picture so that I can actually see, like, okay, are opposite angles congruent, opposite sides? What is this trying to tell me? Also, when you label, okay, this is quadrilateral A, B, C, D. That means that it needs to follow that order. A to B, B to C, C to D, in that order. Okay. All right. So it tells us that A is congruent to C. It tells us that BD is the perpendicular bisector of AC. And then it tells us that angle B and angle D are not congruent. Okay. Now, even though this looks weird, okay, because I drew it, now I'm able to see something. So it has one pair of opposite angles that are congruent, okay, A and C, and it has one diagonal that's a perpendicular bisector. Okay. These two properties, the only quadrilateral that has these two properties, okay, is a kite. It has, so if I were to draw this picture correctly, okay, and adjust my drawing, okay, B and D would be on these ends, A and C would be here, these are congruent, okay, and this is my perpendicular bisector for the other. Okay. So this shape is a kite. All right, for number 17, okay, we're going to do the same kind of thing. So I'm going to hypothesize, okay, make a guess. I don't know what this shape looks like, but I'm just going to try some stuff out. Okay, I'm going to label it A, B, C, D. Now I'm going to fill it in with this information. So it tells me that A and B are congruent, and C and D are congruent, but A and C are not congruent. They don't match. Okay. All right. So bringing back our properties, okay, the only shape that has the angles that are consecutive, congruent to each other, but not the angles that are opposite to each other, is the isosceles trapezoid. Okay. So that's what we have here. Okay. All right, number 19. It says if a regular polygon has exterior angles of 30 degrees, how many sides would it have? Okay, so the formula that this goes with, if you have a regular polygon and you're trying to solve for the exterior angle, that's going to be equal to 360 divided by the number of sides. Since, for example, if I had a regular pentagon, okay, it's going to have 5 exterior angles, 1, 2, 3, 4, 5, okay? And I know that the sum of all exterior is 360, so 360 divided by 5 would give me what 1 was, okay? All right, now in this problem, though, we're actually given the exterior angle. We're trying to figure out how many sides does it have. So we just set up our equation like this, but fill in what we're given, and then solve for n. So if n is in the denominator, and we're solving for it, we first need to get it out of there. Those cancel. Now we have 30n is equal to 360. Then to get n by itself, we would divide by 30. Those cancel. N is equal to 360 divided by 30, so that's equal to 12. So this is a figure with 12 sides. All right. Okay. So it says find the fourth ordered pair for all the quadrilaterals. All answers must be on the dotted line. So it wants us to place the fourth point so that this shape is going to create a parallelogram. It also gives us a line, so wherever our fourth point is, it's got to be somewhere along here. Okay. All right. So if I'm knowing that my point is going to be somewhere over here, then I'm guessing that I'm going to have to connect these two sides. So these are two sides of my parallelogram. Okay. All right. Now what we know about parallelograms is that their opposite sides are congruent and their slopes should be parallel, or their opposite slopes should be parallel. So like if this has a slope of 0, then this should also have a slope of 0. Also, if this length, which we don't have to necessarily solve for the length if we can just count the rise and run, and we can do the exact same rise and run over here. So I've got 1, 2, 3, 1, 2, 3, okay? So then that means that this should be up 1, 2, 3, and over 1, 2, 3, okay? Meaning that the fourth point would lie right there. Okay. So that's at the place -2, 5. Okay. All right, so 24a. For this problem, we're solving for the mid-segment of a trapezoid. It's just a simple formula. So mid-segments of a trapezoid are equal to base 1 plus base 2 divided by 2. Okay. So plugging things in, I've got 6 plus 10 divided by 2. So that would mean that this is equal to 8. Okay. All right, if you flip over to the next page, we have one more trapezoid mid-segment problem, but this time you're given your mid-segment and you're trying to find one of the bases. Okay. All right, so what we can do, we can take this formula and plug in what we have. So we know that our mid-segment is 15. That's equal to 9 plus our other base divided by 2. Okay. Now I can just solve this for my other base. So if I'm dividing here, then first thing I would do is multiply by 2. 15 times 2 is 30. It's equal to 9 plus b. Okay. And then just subtract 9. Those cancel. 30 minus 9 is 21. Okay. So in general, whenever you're solving these kinds of problems, it's going to be 2 steps. You're going to take your mid-segment and multiply it by 2. And then you're going to subtract from that your base. And that's equal to 32. Okay, again, our runtime is getting a little long, so I'm going to stop this video, and then I'm going to continue the rest of the review in the next video.